Okay, so draw a line bond structure for vinyl chloride CC2H3Cl, the starting material from which PVC, polyvinyl chloride plastic, is made. So we have 2 carbon atoms, 3 hydrogens, and 1 chlorine. And we really don't know anything more than this. We don't know anything about how these atoms are placed, but we usually start with the carbon, hydrogen, carbon, nitrogen, oxygen, etc. Put those as the main sort of atoms down. And so we have 2 carbons. Let's just put those next to each other because they're probably going to be bonded together in this structure. Hydrogens we can put around later, and same with the chlorine. So we have 3 hydrogens, and let's just start with one hydrogen here, put another one there, and another one here. Actually, let's do it a little differently. Let's just for fun, just put all 3 on 1 carbon. Now we have 1 atom left to fill in here, and that's a chlorine. So we'll put a single chlorine there. Now, does this work? Well, we're going to have 1 bond at least between these 2 atoms, right? The carbon bond. And that gives us 8 valence electrons around this carbon. So this one has the maximum number of valence electrons. Well, we have 4 valence electrons so far around carbon, so now we need to fill in the rest, and the only way to do that is to put in some lone pairs. So we'll put in a lone pair, another lone pair, and now we have 2, 4, 6, 8. So now this should be a good situation, 8 electrons around this carbon, and then we'll just fill in the lone pairs around chlorine, and chlorine has 7 valence electrons, and now it has 2, 4, 6, 8 in its outer shell. So chlorine, carbon, and carbon. They're all good except for the fact that we have 2 lone pairs around carbon. And as you get familiar with organic molecules, this will begin to look a little funny. But even now, we can tell that this is a little bit of an unstable, or actually very unstable, scenario here, because if we count the number of electrons that this atom quote-unquote owns, and this is sort of a preview again to the next chapter where we talk about formal charge, but it's important to really figure out why this structure is wrong here. And this is because if we count the electrons, 1, 2, 3, 4, and then 5 and 6, so that's 6 electrons around carbon. It has 4 valence electrons, so 6 minus 4 is minus 2. So this carbon atom has a -2 charge. And carbon is not very electronegative. And even if it were, a -1 charge is hard enough to accomplish on the second row of the periodic table. Chlorine can be chloride, and that's just fine, a -1 charge, -1, but you rarely see halogens with a -2 charge, much less a carbon atom. So this is just an impossible structure. So that leaves us with one other option, which is to put 2 of the hydrogens on this carbon and 1 of the hydrogens on this, and the other chlorine on this carbon. And then, since we have 2, 4, 6 electrons around this carbon, and then 2, 4, 6 electrons around this carbon, the easiest way to satisfy everyone, and it's hard to satisfy everyone, but in this case we can do it, the easiest way to do that is to put a double bond between these 2 carbon atoms. So now, if we count the electrons, 2, 4, 6, 8, here, 2, 4, 6, 8. So again, I'm counting, when I count the outer shell electrons around a given atom in a molecule, I count both electrons in a bond because it's getting to share these electrons. And in order to achieve that stable octet, that noble gas configuration, That's why these atoms come together to share electrons, so that they can all achieve that stable octet. And in this case, both carbon atoms have 8 electrons. Granted, they are sharing, but that's okay. And then the chlorine with its lone pairs as well. So this is the structure of vinyl chloride.